We'll be revising some of the way sampling is done and how we can evaluate the methods.
But first, make sure you're not going to get tripped up by any of the technical terms. The target population is all the people who might have been studied. So we've said what sampling is. The next thing is to check out how it's done.
One way of doing this you'll probably know is random sampling, where every member of the target population has an equal chance of being selected. So it's the same principle as the lottery.
Another type of probability sampling you need to make sure you know is stratified sampling.
In stratified sampling, selection isn't just left to chance, it's manipulated to try to ensure a better reflection of the target population.
When you're revising correlations, think relationships. This is the key word or image to keep in your head, because that's what correlations are. They're types of relationships.
Correlations measure the extent to which two or more variables are related, and correlational analysis usually starts with a hypothesis, something you'd expect to find. So, for example, I might expect to find a relationship between the amount of time my students spend on their schoolwork and their grade.
And we could do a correlation analysis to find out by looking at, for example, time students spend revising, T, and their grades in class, G. Correlation coefficients are calculations that measure the strength of a relationship, and the closer the number is to +1 or -1, the stronger the correlation is.
It gives us precise, measurable data on the relationship between two or more factors. So it can tell us if there is a relationship between revision time and grades. And if so, is it positive or negative? And what's the strength of that relationship? But correlations also have important limitations.
When you're looking at psychological statistics, it's important to distinguish between those that are just identifying relationships between things or variables, and those that are claiming more by suggesting that one variable is actually causing changes in another. And if the statistics are telling us this bigger story of causality, then we need to know how the researcher has moved from correlation to causation.
Just as we have made choices about what to wear for a special occasion, for example, so researchers have to make choices when they're planning an experiment.
We're going to illustrate experimental designs with a memory question we hope will be relevant to you as students. What's the best time of day to revise for exams? Morning or evening? So let's imagine we're doing an experiment to find out.